Sorry about that. The last video froze on me, so I just had to start a second one real quick. So again, just plug in your velocity function, 1/4 sine, in this case, x dx from 0 to t. So we have negative 1/4 plus we know that it's negative 1/4 cosine x. And don't worry that we changed the variable to x and dx. It's just a placeholder because, again, we are going to integrate that from 0 to t. So we have negative 1/4 minus 1/4. I'm going to pull the 1/4 out, and we have cosine t minus, well, cosine 0 is simply 1. And if we then distribute the negative 1/4, we get positive 1/4. They cancel away, and we are left with negative 1/4 cosine t for our s of t. You get the exact same answer that we got before, just a slightly different method and different way of completing the problem. The last thing I just wanted to go over real quick, again, this is just a short extension of the last video because my recorder just froze on me, is you can then take this idea of position, velocity, and acceleration and apply it to any type of net change, right? So in general, suppose we have some quantity, we'll just call it Q, okay? That changes over time. And it can be anything. Production cost can change over time. Cell growth can change over time. Anything. As long as you know that rate of change at a known rate, we'll call that Q prime, then your net change of course, between t equaling A and t equaling B is Q sub B minus Q sub A, which is going to be equal to the integral from A to B of Q prime of t dt. And the same idea as before, given an initial value of Q sub 0, the future value of Q, of your quantity, whatever that quantity happens to be, at some time that is greater than 0, you can use the same idea. Start with your initial and then add your function from 0 to t of Q prime, and again, you can just use x as a placeholder. And that will work for a lot of different net change functions. So we can take a look at a real quick one on cell growth. So let's suppose a culture of cells in a lab has a population of 100 cells. When some nutrients are added to those cells, at t equaling 0. So we have 100 cells in a culture, and we add some nutrients. Now, suppose the population, suppose n sub t this is the population of cells. So the number, n sub t, in, let's do this in cells per hour, increases at a rate, so this is a rate, so this is our derivative, 90 e to the negative 0.1 t for any t greater than or equal to 0. Okay, so according to this function that we still have at the top of our screen, we can say that the number of cells we have at any given time, or the to find n sub t, the future value of the number of cells, it would be equal to the initial, sorry, that keeps popping up, the initial value, right, plus the integral from 0 to t of 90 e to the negative 0.1 t. Oh, we're going to change that because, again, because we're going from 0 to t, we just have to put x in as our placeholder here. And that allows us to solve it. And we can do this. We know this is 100. That was our initial value. All right, so we have to integrate. You're going to use your u sub here. And just real quick, in case you don't remember, I would have u equal to the negative 0.01x, so then du over dx, which means du, is negative 0.01 dx. And dx then equals du divided by negative 0.01. In doing that, that would give us our 90 e to the u, and replacing dx with du, and then you would divide by that negative 0.1. Sorry, I wrote wrong on here. Let me fix that for you real quick. It was negative 0.1, negative 0.1, negative 0.1. So you have to use your u sub rule there. So if you go ahead and do that, you will end up with your 90 over negative 0.1 e to the negative 0.01 x from 0 to t. And that's going to give you 100. If you do 90 to, so you got to plug in t. Here, we'll do it all. By the way, 90 divided by negative 0.1 is negative 900 e to the negative, sorry, 0.1. Apparently I wrote it wrong there as well. T, right? Then minus, again, 90 divided by is negative 900. And when you plug in 0, you get u to the 0, which just comes out to 1. So it's, this ends up becoming plus 900. So this becomes 1,000 minus 900 e to the negative 0.1 t. And that ends up being our function. So this is it for a review of velocity and net change for today.